Hi class, in this video we're reviewing for our Unit 3 test on proving triangles are congruent. For the first question, CPCTC stands for corresponding parts of congruent triangles are congruent. As an if-then statement, if you have congruent triangles, then the corresponding parts are congruent. In the next question, to be able to prove that triangle BCD is congruent to triangle DEB by side angle side, using the two given congruent corresponding sides, so that's this side BC is congruent to side DE, and side CD is congruent to side BE, we would also need a pair of angles. So we would also have to know that the pair of angle C is congruent to angle E. So that's question C here. The next question says, which of the following is not a criteria for proving two triangles are congruent? That's angle, angle, angle. Either angle, 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 or side, side, angle are not criteria to prove triangles are congruent. Number 4, which triangle congruence criteria will determine congruence for the given diagram? Okay, so this given diagram, we have these vertical angles right here. We have this pair of angles, that angle A is congruent to angle E, and this pair of sides. So marking the congruent vertical angles, then in looking at one triangle, on one triangle we have a congruent angle here, a congruent angle here, and a congruent side here. So that's angle, angle, side. This next question says that 3 of the 4 items listed can be used to establish congruence by side angle side. Determine which one is not needed to prove the triangles are congruent by side angle side. So D is congruent to C. Angle D is congruent to C. We have B is the midpoint of CD. B is the midpoint of CD. And B is the midpoint of AE. And angle DBE, and angle CBA are vertical angles. So marking up this diagram, we have the vertical angles, that's here, and we have B as the midpoint of AE, would mark these sides equal. B is the midpoint of CD, would mark these equal. So A congruent to, or D congruent to C is not necessary. Next question says, which triangle congruence criteria will determine congruence for the given diagram? So we could mark the vertical angles, and then looking at one triangle, we have this angle here, this side, and this other angle. So that's angle, side, angle, which is answer C. So here's a syllogism problem. If our family goes camping, so that's situation A, then we will catch fish for dinner, that's B. If we have a long weekend, that's something new, C. Our family will go camping, that's A. And if we catch fish for dinner, we saw that before as B. I will have to clean a fish, that's something new, so that's D. So we have A implies B, C implies A, and B implies D. So putting this in order, I can put this statement out front. Then we have C implies A implies B, and B implies D. Therefore, situation C is if we get a long weekend, then D is I will have to learn to clean a fish. Then I will have to learn to clean a fish. In this problem, we have to provide a specific example of inductive and deductive reasoning. So an example of inductive reasoning is based on patterns. So for example, 2, 4, 6, 8, the next number would be 10. For deductive reasoning, Deidre knows that she cannot wear hats in the classroom because of the handbook. So when she reads it as a rule, then that is deductive reasoning. Deductive reasoning is the application of rules to situations, rather than noticing by patterns that no one else wears hats, so she knows not to wear a hat. That would be an inductive version of it. In the next problem, given quadrilateral ABCD is congruent to quadrilateral WXYZ, complete the following congruent statements. So angle B would be congruent to angle X. Segment WZ would be congruent to segment AD, because they're in the same place since the order matters for congruence statements. Angle BCD is congruent to angle XYZ, and segment CD is congruent to segment YZ. And number 10, in triangle ABC, the included angle of AB and BC is. In order to figure this out, let's draw a picture. So drawing out triangle ABC. And then we're looking between segments AB and BC. So right in between segments AB and BC is angle B. So angle B is the included angle. It might be difficult to determine without a diagram, so the key is to draw the diagram, and then we could answer that. In this problem, we do not have to fill out the inverse, converse, and contrapositive. We only have to do the conditional, hypothesis, and conclusion. So the conditional is the if-then statement. The hypothesis is just the if part, and the conclusion is just the then part. So as an if-then statement, this would be, if a quadrilateral has parallel sides, then it is a parallelogram. The if part would simply be a quadrilateral has parallel sides. And the conclusion would be it is a parallelogram. And the truth value for this is that it is true that if a quadrilateral does have parallel sides, it is a parallelogram. I'm not a huge fan of how it's worded because a parallelogram would need two pairs of parallel sides. So it's unclear as it's written if it's talking about two pairs of parallel sides or a single pair of parallel sides, in which case it would be a trapezoid but not a parallelogram. In this problem, I'm given that M is parallel to N, and I have to prove that angle A is congruent to angle G. So here's angle A and here's angle G. So those are corresponding. So I'm really proving that angles are congruent, that are corresponding. So I'm not allowed to use corresponding. I'm allowed to use all the other ones except for that. So one way to do this is to pick another angle which is congruent to these, such as C. Then I could say angle A is congruent to angle C because they're vertical. And angle C is congruent to angle G because they're alternate interior. And therefore, angle A is congruent to angle G by substitution. That way I'm substituting out the C and in the G. So there's my substitution. In this problem, given that M is parallel to N, I'm looking to prove that angle B plus angle F equals 180. So those are same side exterior. So that's the rule that I'm not allowed to use. So that means I'm allowed to use any other rule. So I'm going to get one angle that is a linear pair to both of those. So if I choose A, then I could say that measure of angle A plus measure of angle B equals 180 because it's a linear pair. Then I could say that angle A is congruent to angle F because they're alternate exterior. So therefore, measure of angle B plus measure of angle F equals 180 degrees by substitution. That I'm subbing out the A in the F. And there I have it. In this problem, the directions are unclear, but we're looking to find what x equals. So the goal is to find what x equals in this problem. So to do that, we could mark up our diagram. So we have a linear pair right here, so that angle has to be 50 because those two angles have to add up to 180. And then the three angles on the inside have to equal 180. So 24x minus 2 plus 19x plus 3 plus the third angle, which is 50, has to add up to equal 180. Then I could solve this equation to figure out what x equals. So combining like terms, 24 plus 19 is 43x. Negative 2 plus 3 is 1 plus 50 is 51 equals 180. So that means that 43x equals 129. So dividing by 43 to both sides, x will equal 3. So x equals 3. If I wanted to, I could fill that back in to figure out what the angles actually equal. In this case, this would equal 70. And the other one, we would have this equal to 60. In this problem, we have a linear pair going this way. So the top vertex angle of the isosceles is 78. And since this is isosceles, then these base angles have to be equal. So those base angles are going to be 180 for the three angles minus 78, so that's 102. And then equally spaced, so 102 divided by 2 is 51. So each of these angles here are 51. Then we have vertical angles, so that's equal to 51. Both of these base angles are the same, so this angle has to be 51. And we have a linear pair to complete this angle. So x is going to equal 180, take away 51, which is going to be 129. So x equals 129. In this problem, we could find the missing side by using Pythagorean theorem, a squared plus b squared equals c squared. So we're going to have 9 squared plus x squared, those are the two legs, and that's going to equal the hypotenuse squared, which is going to be 14 squared. So that's going to be 81 plus x squared equals 196. So taking away 81 from both sides, we're going to get x squared equals 115. So square rooting both sides, x equals the square root of 115. As a decimal, that is approximately 10.72. For this problem, given that angle B is congruent to angle E, so I'm going to mark that angle B congruent to angle E, and segment EA is congruent to segment BA, And we can also mark these vertical angles right here. So those two triangles are going to be congruent by angle, side angle. Writing that up, angle B is congruent to angle E because it's given. So there's the angle. Then we're going to have a pair of sides and a pair of angles. So the pair of sides is going to be EA is congruent to BA because it's given. And the pair of angles is going to be angle. I need 3 letters for this busy region in the middle of the diagram. So angle EAD is congruent to angle CAB because they're vertical. And therefore the triangles are congruent. So triangle EAD is congruent to triangle BAC by angle, side angle. In this problem, we're trying to prove the two triangles are congruent. So we're given CB is parallel to ED. So that's already marked. And CA is congruent to DA. So let me mark that. That CA is congruent to DA. And I could mark my vertical angles. And because I have parallel lines, I also have alternate interior angles. So those are right here. So I could also prove that these triangles are congruent, in this case by angle, side angle. There's different ways of doing it. It is possible to do it with angle, angle, side, but here's one way. Okay, so now writing this up, I can say that, so starting with my given, segment CB is parallel. CB is parallel to ED, because that's given. And CA is congruent to DA because that's also given. So then I have a pair of angles. Angle C is congruent to angle D because it's alternate interior. And I have angle CAB is congruent to angle EAD because they're vertical angles. So therefore the two triangles are congruent by angle, side angle. So triangle EAD is congruent to triangle BAC because of angle, side angle. 2 more proofs. So in this one, BD bisects angle ABC. So angle ABC is this large angle right there, and it bisect means to cut into 2 equal parts. So this angle is going to equal this angle. And then BD also bisects the bottom angle ADC, which means that this angle here is equal to this angle here. We also have the reflexive side. So we could prove these triangles are congruent by angle, side angle. Okay, so writing up this proof, I'm going to start with my given that BD bisects angle ABC because it's given, which allows me to say that angle ABD, that's this angle ABD, is congruent to angle CBD by the definition of bisect, or a definition of an angle bisector. Then BD bisects angle ADC because it's given, which allows me to say that angle ADB is congruent to angle CDB by the definition of bisect. And I also have my reflexive sides. So side BD is congruent to side BD because they're reflexive. So now I have my 3 congruent statements. 1, 2, 3 stars. Therefore, the two triangles are congruent. So triangle ABD is congruent to triangle CBD because of angle side angle. And now that the triangles are congruent, I can say that the unmarked parts are congruent. So I can say segment AB is congruent to segment CB because the corresponding parts of congruent triangles are themselves congruent. In this last proof, I have overlapping triangles, so I'm going to start by drawing them separated. So drawing my first triangle separated. And that's triangle ACE. And that's separated from ABC, which is going to go like that. So here's A, B, and it's actually D. So here's my vertex D. Okay, so I'm marking up these triangles. AB is congruent to AE. So I'll use AB is congruent to AE because it's given, and AC is congruent to AD. So AC is congruent to AD, which is on the bottom there. And we're also going to have angle A is congruent to angle A because they are reflexive. So writing up this proof, we're going to prove that these two triangles are congruent by side angle side. Okay. So AB is congruent to AE because it's given. Then for the angle, we have angle A is congruent to angle A because it's reflexive. That's that shared angle that's on both of the overlapping triangles. And AC is congruent to AD because it's given. So there's our side, our angle, and our side. So therefore, the two triangles AEC is congruent to triangle ABD because of side angle side. Thank you for watching.